I'm Steve Helmer. I'm a flight test and demonstration pilot for Textron Aviation Defense, and right behind me is the M-346 aircraft, and we're going to do a quick walk around and talk about some of the features of the airplane. The airplane is a twin-engine, fly-by-wire, advanced jet trainer, tandem cockpit. You can see two HUDs. There's one in each cockpit, and the rear seat is stepped up significantly to give the instructor better visibility from the back. Starting at the nose of the airplane, one of the key aerodynamic features we see on this aircraft is the chine. So you have a leading edge extension coming off the wing with the vertical fin there, and that continues almost all the way down to the nose, and that gives the airplane superior high angle of attack handling qualities, similar to a Hornet or an F-35. So it makes it a great lead-in trainer for that. Obviously, the landing gear is robust, but this airplane is not designed for landing on an aircraft carrier. The Navy has signaled to us that they are not looking for that. So it's optimized for field landing performance, which allows us to keep the structure a little bit lighter and again, maximize that performance. The main landing gear design that you see here, obviously very robust design already, but if we need to bring back FCLPs or aircraft carrier operations into the syllabus, this gear would need to be reinforced. So the gear itself would probably be converted to a trailing link, and then we'd be looking to reinforce the structure as well. Back here we have the twin engines, so Honeywell turbofan engines. Each one develops 6280 pounds of thrust. So that's giving you about a 0.7 to 1 thrust to weight at takeoff. We've got leading edge flaps with the notch here. That reduces wing drop. That's going to give you better handling qualities at high Mach as well as high angle of attack, and it's going to allow the airplane to fly a lot smoother. It really carves through the air. So this is one difference with this aircraft is it's the prototype for the fighter attack variant, which means it does have the wingtip pylons. These are not on the trainer. So that's just a minor difference between the two airplanes. And then here we have the trailing edge flaps. These are automatic, just like they would be in any digital fly-by-wire airplane. The ailerons droop as well in the approach configuration to minimize approach speeds. You're landing at about 120 knots, maybe a little bit less. So it's very comparable to Gen 4 carrier-based fighters. All moving stabilator. This is a transonic airplane, so you're getting about 0.93 Mach straight and level, and then in a shallow dive, it'll go right through the number out to about 1.15 Mach. So definitely a high-performing aircraft. One thing, this large antenna you see here is kind of the meat of the mission. This is a data link antenna, and that's allowing the aircraft to talk to ground stations and other aircraft through the ETTS, or Embedded Tactical Training System, which is really the heart of the M-346 training system. That allows us to network jets together, network the jet together with other simulators and ground-based stations, and we use a live virtual constructive environment using live things like the aircraft, virtual tracks that we can inject into the system, and constructive tracks that we can generate to simulate surface-to-air threats, other aircraft, and friendlies. One thing that the M-346N will have is the 5 pylons. So there's 2 on each wing, underwing pylons, and then 1 on the center line that's not currently installed. And that will give the operator flexibility to mount up to 3 fuel tanks, as well as practice bombs and light or heavy inerts as the syllabus desires. The vertical fin, similar to if you have background knowledge on the F-18 aerodynamics, this serves a very similar purpose. That adds energy to the vortex, and it helps keep the airflow attached at high angles of attack. So just like that leading edge extension I talked about before, that's actually adding energy to the flow and allowing the airplane to handle better at high angles of attack, and it handles very, very well. Leonardo advertises it as carefree handling, and that really is true. Anything up to the maximum AOA that the jet will give you, it's going to handle just fine. We have multiple AOA probes on the front because you've obviously got to sense what's going on, and multiple redundant systems. The importance here is redundancy in training. So we have 2 motors, we have a quad redundant fly-by-wire system, and an airplane that handles very, very well with a high thrust to weight ratio. It's a sports car. It's a lot of fun to fly.